Hey everybody, Adam here from Autodesk. I'm a technical specialist here in Sydney and I look after everything related to civil infrastructure. Today's webinar is going to be on streamlining your bridge workflows and showing how we can start to design our bridges in Infraworks, take that out to Civil3D to refine the alignment, bring that information back into Infraworks and then push that information out into the Revit environment for some bridge detailing. So what I might do is just start with this model here that we've got set up. This is a site in this vicinity here that our team has been working on. You can see we've already got a structural Revit model in there. I've done some component roads, and this area is sort of almost ready to start to do some sort of traffic simulation and different types of analysis. It's also worth mentioning that we have got this terrain surface in here, which has come from Revit, and it sort of enables a really accurate platform to start your road design. You can see if you look down in this part of the site, that road's a little bit undulating, and if I spin this around, you can see that this region here is much nicer because it's come from a tin survey. So let's say you're in a planning stage and you want to put a new road in an area, and you've identified that we're going to put a road from here over to this and join these two communities together. Infraworks is a great tool to begin that process. So what we can do is we can look at our area and say, okay, where do we want to put our new road and then our bridge over this little creek or through the valley here, which would limit, I suppose, the amount of earthworks that you want to have to deal with. So what we can start to do, really basic, is sketch some roads. So go up to the roads tool. For this instance, we'll just put a basic asphalt road in there, and we might just start from over here. Now, looking at this, we're going to come down through this part of the valley here. It seems to be nice, nice gradient. We'll go across here. Let's have a bit of a look. Where do we want to go now? We'll go up there a touch, and then zooming in, let's join back into this road there. Okay, so that's a really basic road profile. In Infraworks, you've got the ability to start to change the values here, so we can raise the road up a little bit there to reduce the amount of cut we have to deal with, and similarly we can bring this up as well. You can see where our bridge is going to be. Okay, so if we're pretty happy with that, from here you can you could spend more time in Infraworks adding some city furniture such as cars or people, or you could also add some more buildings and things like that to sort of start to visualize your design for your stakeholders. But for this instance, we're going to get straight over into Civil3D and have a look at refining this alignment a little bit more, and then bringing it back in, and then we'll start to manipulate a bridge. So I'll just jump up into a plan view here, and I will export out of here a IMX file. Now I'm going to use a bounding box, and I just want to select that area and capture all of that road. Double click, and there's my bounding box. I'm just going to dump it in my documents here. It's also important to know that that coordinate system has been defined. So hit the export button. Yes, I will replace it, and that's done. So if we jump up into Civil3D now, this is a site that I've already created of ensuring that the coordinate systems are all set up. You can see down here, this is the previous site where we started, where I was quickly talking about. And now you can see that this area over here is where we've just sketched that really basic alignment. So what we're going to do is we're going to bring in the Infraworks model. In this instance, we will import it just navigate down to that IMX file, click open, and you'll see it's brought in a tin surface of the existing terrain, and it's also brought in that alignment as well as some other alignments from around the street, but we'll ignore those for now. We're not really too concerned with those. So if I turn off the map, you can see here that we do have our tin, which is our existing ground, which is what we're interested in today. And we have our alignment. You can see the alignments come in. It's not, it's not particularly, it's not leveraging radius and different types of curved geometry. So what we might do from Civil3D aspect is tidy this up. Put something in that might represent a little bit more of an accurate alignment, and then we'll go from there. So what we might do is just turn this map on. Now let's say we are relatively happy with this alignment, the location of it. We're going to refine it. I'm just going to delete it. There's also some tins in here which I'll just clean up before we go. Okay. All right. So let's come over here. I'm not a road designer, so probably not going to win any awards for my design here, but I'm just going to sketch some curved geometry. So we'll sketch with some curves. We're going to come in here and we'll just start to place our alignment down the valley there, around the corner. Our bridge is going to be somewhere in there, and we will come back up the hill and end up there. Okay, I think that's good enough for what we need. Now you can see that that's much more of a true sort of Civil 3D type of alignment. And yeah, if you're a designer, you're going to refine that and make sure it works. But for this demonstration today, that's going to be good enough. So what we'll do is just turn off the aerial image, and then we'll start to create a profile of this area here. So let's just select our tin. We are going to create a quick profile, and sorry, let me do one thing here. Let's give this a new name. We will call this new bridge design. Okay. Going to create our profile. The alignment we're using is our new bridge design, and we are going to use the existing surface there. We're going to quickly skip through here. Let's just keep this at 1:1. I'm using the RMS country kit because I'm in New South Wales, so that is familiar to me. And for now, we will just we'll leave all this stuff at the bottom, and we'll go from there. Place that in this instance here. Now you can see that that is our existing ground profile, which follows this alignment. What we'll do next is we will add a profile, a design profile here, and then we can look at creating a corridor. Click the profile creation tools. Now our style is just going to be our design conceptual. We'll call this new profile, new bridge profile. Click OK, and we will start to sketch quickly through here a bit of a design, staying pretty close to the existing ground surface. And there's our bridge, ended up there, and let's just take this up to that point there. Hit escape, and now you can see we've got a bit of a profile, vertical profile that follows or deviates from the existing ground surface where our bridge is going to be. Okay, next we're going to create a quick corridor here which will utilize this alignment and our design profile that we have just created. So we will call this bridge corridor. We'll keep that style as is. We're going to do our new bridge design alignment. The profile that we're going to use is our new bridge profile, and we are going to use an assembly which I have just created. It's a super basic assembly, and I'll show you a little bit more on that shortly. And our target surface is going to be our existing ground AIW, which is Autodesk Infraworks, so I know that's where that's come from. Click OK. Hit OK, and we have a really basic corridor in there. Just hit save on that drawing. Now if we come back over to Infraworks, let's just delete that road that we have created, and we're going to import the Civil3D DWG. By the way, it's also worth mentioning, let me jump back into Civil3D for this. I am using the new Civil3D BIM 360 design tool for all of this work. So if I just show you quickly how this looks, BIM 360 design, Autodesk ANZ, Qualcomm is the project, and all of my files are going into this location on the cloud. Now this is sort of similar to Revit Cloud Work Sharing or C4R that people would be used to. This is currently in beta testing. Anyone has access to this. I believe it is scheduled for release sometime later in the year, but before Christmas. And it's really good. It allows people to save their models to the cloud as opposed from working on a file server, and it enables teams of people to work from anywhere. So back over in Infraworks, going to select that Civil3D DWG. You can see I'm accessing the information up on the web. That's the bridge that we are working in, or the model we are working in, sorry. Connecting to the data sources. Now we have a few options here. We're not too concerned about the surfaces because they have come from Infraworks, but what we are concerned with is the road here. Hit OK. That data is getting added to our roads. If I configure this, you can see it's talking to BIM 360 here, so we know we're accessing information on the cloud, which is awesome. You can see now that I'm going to only want to work with the new bridge design road here. Geolocation is fine. I don't want to drape it in this case. And let's click a style, and let's just do, we'll do a bridge 4-lane. See what that looks like. Close and refresh. Now you can see this is our new alignment that's come from Civil3D. If we spin that around, you can see the Z value or the RLs of the bridge match that from Civil3D profile that we sketched, and we know that the vertical alignment here is it's exactly as we have designed it so in Civil3D. So now we're going to focus on the bridge in particular. Click this road, and we're going to add a bridge. So we want our bridge to start back here. Let's end it, it's a pretty long bridge, we'll end it about there. Double click. And there's our bridge. Quite basic, but enough to start to work with from a concept design perspective. one thing I like to do is when I first select the bridge, you have the ability to turn off certain aspects or certain elements of the bridge. In this case, I've turned off the road and the deck and generic features. So when I end up selecting my bridge, you can see that there we are now looking at the girders. So let's do a little bit of work with the girders just here. So because we're in Australia, we want to work with some Australian type girders. So let's change those to a T5 Open Super T. Double click. We'll also change the internal girders to the same one. You can see we have those girders in there. I'm also interested in providing a bit of a gap here, so I'm going to change that to 0.05, 50 mil gap. You can see there is a gap there between the girders at the start and the girders at the end. Once I'm happy with that, I can apply that to all the girder groups. So now you can see we have our Super T girders along this bridge with the gaps as so. Let's focus now a little bit on the piers. So we have some flexibility with the piers. We can change the ends if we want them to be round. We can also play with the depth, the widths, things like that. In this case, I would like the columns to be completely round. And I would like to change this to have 3 columns. There we go. You also have the ability to play with different settings for the bearings and also the foundations. But for this exercise, just because of the time, we won't worry too much about the foundations. I'll kind of want to get into Revit and then show you what we can do over there. So if we're happy with our bridge here, what we need to do, so if we're happy with the piers, we need to apply that to all of the piers. Great. So you can see how quickly we've come up with although it is a basic design, look, we probably need to refine this a little bit here to get it out of the way. We've come up with a really basic design of a bridge that is directly linked to the Civil3D alignment pretty quickly. It's quite impressive how quickly we can come up with something like this. So the next part is we can send this out to Revit and we can start to play with that in a little bit more detail. So what we need to do is we need to select the bridge. Let's put on all of the visibility again. And we will also click the Send to Revit. We're going to create a new model now because I haven't got an existing model, but you have the ability to update the existing model if you already have one open. So let's click New. We will save this just for today's exercise on my desktop. We'll call it Qualcomm Bridge 1. Okay, let's save. We want to keep that proposal and we want to work with the Infraworks template. You can see here that you have the ability to work with the structural template or the Infraworks template. Let's just keep Infraworks now. Hit create and we just have to wait for a couple of minutes for this to send to Revit. So it's taken about 5 minutes for this process to finish. Now it's opened up Revit on my other screen. If I just bring this back here, you can see that there is our bridge that's come out of Revit. Out of Infraworks. Let me just jump to a 3D view here. I might turn the shading on, and we'll turn off these levels. So you can see here, the bridge is here in Revit. Now, this would take someone a very long time to model this without some quite complicated Dynamo scripts or something like that. It's quite impressive how quickly this process has happened. So what I wanted to do now, while we're in Revit, you can start to cut sections through your bridge and look at plan views and start to put together a high-level general arrangement drawing for, let's say, your 20% detailed design delivery. And some important information that needs to be shown on a set of drawings at an early concept phase is levels. So what I've gone and done is I've created a Dynamo script, which I'll show you guys, that's going to interrogate the bridge deck, and based on some inputs that we provide, it will determine the deck levels and then drop a little family in there with the RL information as a parameter, so it can be scheduled also and can be tagged on your documentation. So let's see how that looks. Before we can do that, we need to insert into the model the family that I've created. So I'm just going to load the family in quickly on my desktop. It's called generic model deck point. You can see it's a little 3D arrow, and if I show you what it looks like, it's quite simple. Create instance, and we can place it there. So you can see this family has some parameters for eastings, northings, and RL, and we'll get to that a little bit later when it comes to using Dynamo. So the way I've set up this script, the user needs to define some centerline geometry. Documentation usually would say, the RL of the deck at the centerline of the piers. So what we need to do is put some curves into this model, which will show where the centerline geometry is. So I'm just going to jump into a plan view here. Let's turn this to a wireframe. And we are going to, let me just double check to make sure the category's turned on. Lines are on, good. We're going to insert some model lines. So coming down here, we can snap to the center of this pier. We can snap to the center of this pier. And let's extend that out by a bit. I'll keep a little bit more, 35 meters, just so we can see those curves there in plan. We're going to do the same thing on a few more piers. For this exercise, we'll just do one more. Okay, those pier center lines are done. What I've also gone and done is I've inserted a DWG file of our alignment that's come out of Civil3D, just to make it a little bit simpler to get the control line of the bridge here. So it's just the way as similar to the way that I've put in the model lines through the center line of the piers. Going to do the same process here. I'm just going to use the pick line method to pick up those control lines there. Turn that back off. Now you can see there's some model lines that follow the control line of the bridge. We've also got some transverse or pier center line model lines, which we're going to now use in Dynamo. So let's fire up Dynamo. there's a script I've prepared called Qualcomm Bridge Levels. Fairly simple script. There's three starting points to it, and the end of it is updating some parameter information and then placing the family before that. So what we need to do is we need to select our bridge deck. So let's see, let me just get this over here. Got a view here set up where I can select the bridge deck. I can select that. Next one is select the longitudinal center line. So that's the control line. Select those curves there. And the third one is our transverse center lines. So if I just go back to a plan view here and select those elements like that. Okay. Now, what's going to happen is it's going to take the bridge deck and essentially project up the intersection points of the longitudinal centerline and the transverse centerline onto that deck surface. So to show you that in maybe a little bit more detail, wherever the centerline of the bridge intersects with these curves, it's going to project that up vertically onto the top of the deck here, place a family instance, and then report the RL values. So if I hit run, you can see that it's worked. So what's happening here is it's bringing in the centerline geometry. I'm joining those curves together because those model lines were separate curves. I'm also bringing in the transverse or pier centerline geometry here. What I'm doing, I'm just creating a plane way up high above the bridge, out of sight, just to make it a little bit easier down the line, because I'm going to project the points from the intersection of these two curves straight down vertically, which is where you see here point project. And then that. It just makes life a little bit easier having a plane up high to do that sort of processing. So pulling some curves onto that plane that I've created here, I'm intersecting those two geometries. So you can see here there's 3 points that have intersected one another. Clean that up a little bit, and then I am projecting those points onto the surface of my deck, and what you end up with is 3 points here, X, Y, Z. Then the family that I'm going to place here is called generic model deck point, which is the one I've recently loaded in, and then after that I'm going to add the parameter, taking the Z value information out of the projected point here, driving that into the value of the RL parameter. Now if I hit run again, you can see now back in my Revit model, I've got those families that have been placed in the model, and it is reporting the RL value of 69.207. Similar to that one, and similar to that one. So if I turn that into a plan view, what's happened there? There we go. You can see that that's where that instance of the generic model instance is, there, and there. And you can see the blue curve, which is the center line of the bridge, or the control line of the bridge, not necessarily the center line. So that type of process in Dynamo is, something's happened there. So that type of process in Dynamo is something that can be used through your early stage concept design, or getting up to 20% detailed design to put some information on the bridges, such as the design surface level here at each of the pier center lines. I mean, it's pretty straightforward to create views and cut sections So I didn't really want to show you guys how to do that. I thought I'd show you something else using a little bit of Dynamo. So I suppose in summary today, I've shown you how you can start off with a really simple road design by a planner or someone else in the design team. Bring that information into Civil3D, really refine that alignment to your to the proper standards, and then assign vertical profiles to that alignment. Bring that information back into Infraworks, where we can really quickly start to sketch a bridge and get something pretty nice with correct span lengths, and girder lengths, and spacing between the girders, and all that kind of information. And then send that out to Revit, which, as I said, took about 5 minutes to get that Revit model. And then from here, you can start to really look at putting your drawings together quickly using sections and elevations and plans. And then, as I've shown you with Dynamo, the ability to just extract some data out of the model, which is useful on documentation. So that's it for today. If you guys have any questions, you can get me on LinkedIn, search my name, Adam Walmsley, or email me at adam.walmsley@autodesk.com. Thanks, guys, and look forward to speaking to you soon. Bye.